Okay, let's get back to this. So again, we have this. So whenever you have a negative, if you have parentheses, that negative is part of the base. So when you evaluate, you repeat the negative. If you don't have parentheses, the negative is not part of the base. It's a standalone number, just like a -1 here. Think of it as a -1. Okay, think of this as a -1 here. And also a -1 here. Same thing here, think of it as a -1 times 5 to the second. So the -1, you bring it over here. Then you do 5 to the second, you expand it. And then once you expand it, you have 25 here times -1, which is -25. Now let's do another example. What if you have this, a negative? We saw negative base with the exponents, that's good. What if you have a fraction? If it's a fraction, basically, say you have 2/3, and might be like this. What's the base and the power here?
-2/3.
That's right, this whole thing is the base, so we're going to repeat this twice. So -2/3 times -2/3. Because this is the base, we had to repeat the minus. Then you times, so this is a multiplication. Multiply fractions this way, straight across. -2 times -2, that's 4/9. But if there was no, we didn't have parentheses, let's say you had just -2/3, like this without the parentheses. So this is a little different. First of all, 2 belongs to which number? This power.
2/3. 2/3.
So this 2 to power, what's the base of this power?
2/3.
No, it's not the whole fraction because we don't have parentheses. Only 2.
Okay.
Only 2 is base to this power. This 3 does not get this power. The minus, again, just stays there. Because there are no parentheses, right? The minus. All I have to do is expand this. That's 2 times 2, that's 4. And this stays the same because it doesn't have the power 2, just 3, like this. And that's it. You see that the parentheses can make a huge difference here. So be careful. These may look the same, but they're not. Look at the answers are completely different. Okay, so that's another rule. So we saw negative exponents, we saw negative bases with examples. Now let's see another one, power or exponent 0. What happens when you raise something to the power 0?
Stay same.
It does not stay the same. Let's say 3 to the power 0. What is it equal to?
1.
Is equal to 1. Anything to the power 0
is 1.
Is always 1. That's a fact, that's a rule. We can prove it later if you want, but just remember that. It's not 1, it's not itself, it's always, it's not 0, it's not anything else but 1. Any number, any real number x could be a decimal, could be a fraction, could be anything. Any real number to the power 0 is 1. Be careful if you have something before this. For example, if you have 2x to the power 0, okay, or 2x all to the power 0. Again, the parentheses make the expression different. What do you think 2 times x to the power 0 is?
2.
It'll be just 2, that's right. So the power 0 belongs to x, not to this one because we don't have parentheses. Here, the 0 belongs to this whole thing. The base is 2x, but here the base is x. So 2 basically is by itself. It's power 2 to the power 1. It has an invisible power here, times x to the power 0. What is x to the power 0 again?
1.
1, as we saw here. X to the power 0 is 1. Now you can multiply, you say 2. But here, the whole thing is raised to the power 0. Anything to the power 0 is
1.
Is 1. That's right. Again, so the parentheses make a huge difference. So these are separate problems. This one, and this one. Now, what is negative 5 to the power 0? And what is negative 5 parentheses to the power 0? What do you think this is equal to?
1.
Not exactly 1, but
-1.
should be negative 1. Again, because always identify the base and the power. So the base here is 5, not the negative 5. The power is 0, as we saw earlier here. So the negative, if you don't have parentheses, the negative stays there. Think of it as a -1. Just bring it over. This is what you evaluate. The 3 to the second. For this one, same thing. So this negative, just bring it over. We have 5 to the power 0, which is 1. However, this one, what is the base and what's the power here?
1.
The base
Yeah.
is
The base,
-5.
right? The base,
-5 and 0.
that's right. So the base is -5 to the power 0. Anything to the power 0 is 1. Could even be something like this. X, Y, Z, whatever. Anything to the power 0, but make sure you have parentheses. That's when you say the whole thing is raised to the power 0. This will be 1. But if you had only this, for example, if you had the same thing but without parentheses. So what do you do here? So the 0 belongs to which letter or number here? The power
Z.
0. Say that again? To Z, right?
Yeah.
Okay, so 0 belongs to Z only. So only this will be evaluated. What is Z to the power 0? It would be
1.
1. So the rest stays the same because we don't have parentheses, so this will be -2x, y. Only this Z turns into times 1, which is basically -2x, y. And because anything times 1 is a top. Again, be careful with the parentheses. So that's basically what happens when you have power 0. Anything to the power 0 is 1, as long as the 0 is for the whole thing. If you have parentheses. If you don't have parentheses, only what's directly under 0 turns into 1. Only, for example here, only this one turns into 1, not the 2. Here, the whole thing turned into a 1 because the 0, because of parentheses, this whole thing is raised to the power 0, so it turns automatically to 1. But here, 0 belongs to Z only, not the rest. The rest stays the same. Only this turns into 1. So -xy times 1. The 1 came from Z to the power 0. This times 1 is itself. Okay, everybody on board? Any questions at this point?
No.
Okay.
No.
So it may not, so it doesn't have to seem confusing or anything like that. It's just a bunch of rules. You're gonna get used to them. So make sure you understand each one. That way you don't run into problems in the future. But we're gonna write all the rules. This is just basically examples, but we're gonna write a list of all the rules. There's only about 5 or 6 of them that summarize this whole thing. So let's start with those rules now. Number 2. We call them properties of exponents. You can also say rules of exponents, exponents of powers. And give me 1 second. I had to close the window. It's raining like it's the end of the world. All right, so properties of exponents. Rule number one. Let's say for a real number x to the power 2 multiplied by same real number but to a different power. What do you think this is? X to the second times x to the third. If you want to simplify that into one expression, just one, instead of two exponential expressions, you want to multiply them to get just one. What do you think the answer is?
X to the fifth power.
That's right. So we basically just add the two powers. It is a multiplication here, but the powers add up. You don't multiply. So, but make sure the base is the same first. So 2 plus 3. That's 5. So that's basically maybe the first rule of the properties after the definition here. So one of the very first rules we're going to learn is this one. If you have the same base, so if it's a multiplication, all you have to do is combine the two powers, add or subtract depending on their sign, and you get your answer. You may have something like this with powers that are of different signs. For example, x to the power -3 times x to the power 7. Again, it's a multiplication, same base. What do you do with the powers?
You still add them.
That's right, we just add them or combine them. So -3 here, combined with this positive power, positive 7. The outcome will be, what is the,
4. -4.
not -4, but
Negative 10.
not -10,
Positive 4.
positive 4.
Okay.
So you pick the sign of the higher number, and then the difference of the two. We have different signs, so the difference of 3 and 7 is 4, and we pick the sign of the higher number. Sometimes the powers could be both negative. For instance, this. Again, this, when I put a dot here or a period, it means multiplication. I don't want to put a multiplication sign because it looks like an X. We don't want the expression to look confusing. So dot means multiply. It's not a decimal point or anything. So again, we have the same base. What do you do with powers?
Add them.
That's right. Just combine them. That's right. We're just going to combine them. So -2
Becomes -3.
That's right. With -1, the answer is -3 altogether. But as always, we don't want negative powers. We want to make them positive. How do you make this positive again, as we saw earlier?
You would flip it.
Over.
That's right. Just flip it or move the -1 down. So basically, you're going to move this one down, and the power will turn positive. It will be x to the power 3 or positive 3. So your answers should only contain positive powers. So if you have a power that's negative, just move it to the other side of the fraction. If it's here, move it down. If it's down, move it up, and it turns positive. We didn't have to do anything here because we end up with positive powers. So that's first rule. First property of exponents. Let's make a list of all those. We call these the rules.
First, a quick question. Where you have the 1 over x with the 3, can you just leave it x and 3, or does it have to have the 1 on
This one here?
top? Right here at the bottom, the answer.
Can you get closer to the microphone? I can't hear you.
Do you hear me now?
That's better. Go ahead.
Okay, where it had your answer for 1 over x and the third, can you just put x and the third, or does it have to have the 1 on top?
It has to have the 1 on top.
Okay.
Okay. If it was the other way, that's when you ignore the fraction. If you have something like this, then you can ignore that.
Right.
But this
Okay.
one has to be.
Okay, thank you.
All right. So let's write the rules here. So number 1 is basically for any real number x to a power a multiplied by same number x but to a different power b. What is this equal to?
X. to the power a plus b.
Exactly, a plus b. A and b could be any real numbers, negative, positive, decimal, fraction, whatever these are, just add them up or combine them depending on their sign. So that's rule number 1. Now let's look at rule number 2 of exponents. We saw multiplication here. Let's see what happens if you have a division instead of a multiplication. Let's say you have x to the 5th over x to the 7th. Okay, so what do you think we do with the powers here?
Do you multiply?
Not multiply.
Them.
Say again?
Subtract.
Minus,
Subtract.
subtract.
That's right. So with the multiplication, we add. With the multiplication, we add these two. But with division or fraction, the rule is to subtract the two powers. So 5 minus 2 will be x 3. It's a positive power, so no need to flip it or anything. So also, these powers not always this way. They could be, one could be positive, the other one could be negative, or both. But the rule should be the same. Let's see what happens if, and it's not always this one is higher than this. It could be the other way. For example, 4 and x9. So again, the rule is to subtract the top minus bottom. This will be x 4 minus 9, which is?
-5.
That's right, will be -5. Be careful with your signs here. It's very important that you master your signs of addition, subtraction, multiplication, and division. It's all about signs here, as you saw earlier. 1 minus could make the whole thing different. So now, we're not done yet. We need to make this positive. So we're just gonna move it down. To the other side, it turns into x5. And again, always present your answers, your final answers with positive powers. What if one of the powers is negative? Let's say x to the 3rd over x to -2, something like we already saw. So what do you think we do here? You can always subtract right away. You can say 3 minus -2. It's going to be a double negative, which is, from experience, I saw that it confuses a lot of people. So if you have to subtract, unless you're really confident about your subtraction here, you say 3 minus -2, which is 3 plus 2, which is 5. Or what do we do again when you have a negative power, as we saw earlier? So the fractions here. See these examples. When you have a negative power in a fraction, you want to make it positive. So what's the first thing you do?
You would move it up.
That's right. In this case, we can move this up to make it positive. Do we need to move this down?
No.
No.
We don't, because the power is already positive. So it stays there. Times, and when you move something up, that turns into a multiplication. And that, so this negative power turns into a positive power. Now it's no longer a division, it's a multiplication. So what do we do with the powers again?
You would add them.
That's right,
Add
it
them.
would be x 5. Okay, so when you start with the exponents, if you see a negative power, I suggest you turn it positive first. Unless, again, I said, unless you're really confident with your signs and with your rules, you can subtract right away. But it's always convenient to have positive powers only. So x to the 5th. What if both powers are, let's say, negative? For example, x, something like this. If you were to subtract, if you were to do this minus this, it has to look like this. 3 minus 8. That's if you want to subtract right away. It's this minus this. That's why we have a bunch of negatives. So this can be confusing. That's why I suggest you make these positive first. How do you make these powers positive?
You would flip them.
Then.
So both have to move, right? So if this moves down, it's negative. This one moves up. So end up with x8, x positive 8 over x3. This turns into positive 3, which is, what do you do now with the powers?
Subtract
Add
them.
them.
Subtract. So if you have
Subtract
division, we
them.
subtract, just like we did here. 5 minus 2. Same thing here, x minus 8. 8 minus 3, which is 5. You can skip some steps sometimes, but if you simplify this, you'll get the same thing. If you did -3 minus 8, you would turn the double negative into a positive, so it would be -3 plus 8, which will eventually be 5. Okay, but this, again, can be confusing, but it's probably easier. Once you flip them, as you can see, much easier. You can just say this right away. You don't even have to go through this step. So I suggest you turn the powers positive first. So that's our second rule of exponents. So that's number 2. Let's write it over here. So in general, for any real number x to a power a over same number x to a power b, what is this equal to? X to the power
Minus.
A
A.
minus B.
a minus b. That's right. Whatever a and b might be. Okay, that's our second rule. The third rule is number 3. Let's do that over here. This time when you have something like this, one base to a power and another power over the whole thing. Not two variables, not two bases, maybe 3 here. Okay, just one base of power and the whole thing is erased to another power. How do you simplify this into something simpler with one power? What do you do with the two powers?
Would you still add them?
Not add in this case. So
In this case, you multiply?
you multiply, okay? Glad you mentioned that. So this one and this are not the same. Here we have two bases, two powers, a multiplication, that's when you add. But if you have only one base, these have to be multiplied. So do not confuse this with this rule here. So it will be x and 2 times 3, which is x to the 6. Okay, and this could be positive, could be negative, could be anything. For example, x, let's say -4, maybe 5 here. So again, one base, two powers. What do you do with the powers?
Multiply.
We multiply them, so it would be -4 times 5. So x to the power -4 times 5, which is x
Negative.
to the power -20. But we don't want a negative power. How do you make it positive? 1
You would-
over.
1 over x20.
That's right. x20. That's basically what you do when you have one base. It could even be 2 or more powers. It could be 3 or 4, same thing, just multiply all of them together and you get a simplified answer. So this one and this are the same, but this one is much simplified, x to the 6, as opposed to this one. What if both powers are negative? Let's say -1, -6, for example. I know we mentioned earlier that whenever you see a negative power, make it positive first, for example here. But in this case, with a multiplication, it's better to multiply it right away. That way, this could turn into a positive and you don't have to flip anything. So what is x to the power -1 all to the power -6?
It becomes
X6?
x positive 6.
Right? With just positive 6, because negative times a negative is 6. So it's faster and easier than flipping this and then flipping this. It's a lot of work, so it's easier. So with multiplication, multiply right away. If it's anything other than that, with fraction, I suggest that you turn the powers positive first. So that's basically our third rule. So we're gonna write it here. So again, in general, so for any real number x to a power a, that number raised to a power b, what is this equal to? X to the power
A times B.
A times B, that's right, or simply AB. So when you say AB, that means there is an implicit multiplication there. So AB means A times B, not plus B. If it's a plus, we write it. If it's a minus, we write it. But if it's a multiplication, we just say AB. These are the first three. And the other ones, basically, we already saw them. We're just going to revisit them. Number 3 here. Let's write number 4. So the rest, we already saw them. Again, what is, if you have x to the power negative a, what is this equal to?
1 over
X A.
That's
Positive
right. 1 over x a. That's number 5. Let's number 4. Let's look at another one. So the rest of them, we saw them already. We're just going to write them down. So this is 4. The other one is, what if you have a whole fraction, x, y, the whole thing is raised to a negative power. How do you make this power positive again?
You would flip them.
That's right, we're going to flip the entire fraction. Okay, so if you have an entire fraction with parentheses raised to a negative power, so the negative belongs to the whole thing. But to make this positive, we're just going to flip this upside down, and this will turn into a positive a instead of a negative a. And of course, if they both have 2 powers, like here, then it's technically the same thing. So you move this one down, this one up. Or if only one of them has a negative power, so you only move that one, not the other one. What else did we see? So that's number 5. Number 6. For any real number x to the power 0, what is that equal to?
1.
1. That's right. What if there is a, that's right. What if there is a number a next to the x? What is this equal to? This a could be anything. Could be a negative, could be 2, could be 5. What is this equal to?
A.
1.
Just a. It's just a. So this stays whatever that number might be times x to the power 0. What is the x to the power 0 again? Is
1.
1. And this will be a times 1 is just a. But if you have parentheses, then that turns into another problem. What if you have xa all to the power 0? This will turn into
1.
just 1. That's right. Let me write this. You separate these are separate. So this one by itself and this one is by itself. So again, since this whole thing is raised to the power 0, this turns into just 1. Actually, let me separate these. Okay, so these are separate things. And of course, also we saw negative x to the power 0. In this case, basically this negative is like the a here. The a could be any real number in this case. Someone's negative. So what is negative x to the power 0?
-1.
That's right, just negative 1. Because think of this as there's a negative here, -1, times this. So that's -1 is here times x to the power 0 is 1. This whole thing is -1. Okay, so that's basically the other rule. I think we covered all of them. Let's see. Yep, that's basically all of the rules. There's one left. There's one other rule left. Let's call this number 7. Basically, if you have x to power a times y to power a, what do you think this is equal to? It's the
X,
opposite. It's the
Y.
opposite. It's the opposite of this. You see here we have the same base, but different powers, but this one is different. We have different bases, but the same power. What is this equal to?
xy to the power of a.
Y, A.
Okay, and what do you need with that? We're gonna need to put them in. When you say xy,
Parentheses.
parentheses. That's right, we're gonna need parentheses. Basically, these two share the same power. So we can write them together and say x and y and write them to the same power. Combine them together. So if you don't put parentheses, it will look like a is only for y, but it has to be for both because from here, yes, it's for both. Here's another example of this. If you have, for example, a, b, and c all together and they share some power, let's say d. So all these have the same power. If you wanted to expand this and write each one by itself, each letter by itself, what do? We can distribute this power to everything inside. So the d, because of the parentheses, belongs to all of them. So we can write each one to the third power. So we can distribute that power like this. A, D, B, D, and also C and D. You can go back and forth between these two as needed. Same thing here. You can go back and forth between these. Sometimes you need to go this to this step or go backwards. We're going to see this in detail next time. So now that we learned all these rules, we're going to see how to use them to simplify more complex examples. So far, we saw just one variable, x at a time, but it could be 3 variables here, x, y, z times x, y, z. Same thing with the fractions. It could be x, y, z here over x, y, z. But these are the main rules, and we're going to use them the same way to simplify more complex examples in our next class. But get familiar with all these. I know it was a bunch of rules. I understand that. Just make sure you go over this as many times as possible. Make sure you understand all the rules and how to use them. They're not that hard to use. They're not that hard to actually understand. So just make sure you know the difference between each one of them here. Know when to add, when to subtract, when to multiply, and so on. Know when to turn your powers positive. So basically, this is your main thing here. All the rules are summarized. Everything we saw, everything we explained today, the whole thing is summarized here in these rules. So basically, there's about 7 of them. And we're going to use these to solve a lot of problems next time. And exponential exponents, or the rules of exponents, are very important in this college algebra class. So in addition to what we saw last time with the algebraic expressions, simplifying them, and the real numbers. So throughout this class, understanding the exponents and the way they work will make the rest of this class a lot easier. We're going to be using this in many topics in this course, including simplifying complex exponential expressions next class, including factoring. Factoring is another very important topic in algebra, and factoring basically is based on this. It will be based heavily on power, so understanding powers will make it a lot easier. Same thing with solving quadratic equations or third degree or even higher power equations. With the understanding the rules of exponents will basically make things a lot easier, and things will make more sense. And not only for that, so factoring exponential expressions, equations, and later functions, and pretty much every topic in the future will involve exponents, whether directly or not. So understand this, and in addition to the rules, okay, the rules of addition, subtraction, multiplication, and division. There's no room for mistake in college algebra here. As you can see, 1 minus can make the whole thing different. So master your signs along with this, and this class will be a lot easier for you, and any future topic will make more sense, and hopefully you wouldn't have any issues. Okay, did this, any questions about any of these rules today?
Thank you.
Anybody? Please
No
let me know.
question.
Any questions? I'm gonna
No.
cut this. I'm gonna edit this video and post it to the homework folder. So yeah, you may need to rewatch this. You may need to rewatch this at least once or twice. The more you watch it, the more sense it's gonna make. Okay. And now we covered a lot of things, a lot of examples, but don't worry about it. Just rewatch the whole thing. Focus on these. Always have these in hand. These rules here. And again, this is the foundation of this class. So all of it, if not, I mean, most of it, if not all of it, will be based on this stuff. So understand it, not just remember the rules. You need to understand how they work. And trust me that it will make your life a lot easier in this class. What else? Okay, so like I said, I'll post this, rewatch it. Any other questions in general before we move on?
None so far.